Hello, I'm Silvio from TestCompass, a collaborative modeling tool designed to structure and optimize the test process. TestCompass innovates testing from the very start of the project, assisting with studying, understanding and analyzing the requirements by early modeling, as well as automating the test design, impact analysis and more. In this video we are going to explore, study and test the requirements by creating an easy-to-read graphical model in TestCompass. But let's first take a look at the requirements that we'll use in our example. In our example, we'll be using the requirements of a tool discount system. The manager at MegaTool Marketplace is looking to implement a tool discount system which will incorporate a range of discounts. These include a 4% discount on purchases exceeding €200, a 20% discount on purchases of €100, as well as discounts for buying more than 30 screwdrivers or drawing a colored coupon. This project is solely focused on calculating the different discount scenarios, and at this point only the requirements are present and not the application itself. Okay, let's start by logging in to TestCompass. This can be done by using the login button on the website compass-testservices.com. After we've entered our email address and password, we can log in. Let's first create a new project and name it MegaTool Marketplace. As you can see, TestCompass has already automatically placed the first model under the project. Let's name this model Tool Discount System. Now we can start translating the requirements to a model. A model in TestCompass always starts with a start node, and this node is already included as standard by TestCompass. Now first let's include an action state node, and here we write the text Start Tool Discount System. During modeling, all kinds of red exclamation marks will appear. These indicate errors in the model. We will cover this later in this video. In TestCompass, we can use the balloon node for all our questions, comments, assumptions, etc. We can place this balloon node anywhere in the model, and it does not have to be connected to another node in the model. Let's include now a balloon node at the first action state node and place a comment in it regarding the scope. The next node in TestCompass is the decision node. We use this node for all decisions in the requirements. As in our example, our first decision is whether our purchase is exceeding €200. This gives a discount of 4%. By including these decisions in a model as a separate node, all yes and no branches are intuitively included and make us think about the various test ideas. Our next decision is whether our purchase is more than €100. This gives a discount of 20%. But that's strange. You get a 4% discount if you spend more than €200 and a 20% discount if you spend more than €100. I strongly believe this is an error in the requirements and that perhaps it should not be 100 but €1,000, which entitles you to a 20% discount. So let's include this question in the balloon node. Now we encountered the next decision in requirements to include in our model, whether to include more than 30 screwdrivers. This modeling approach also prompts us to generate test ideas for boundaries and edges. This decision generates test ideas for scenarios with more than 30 screwdrivers, as well as fewer than 30 and exactly 30 screwdrivers. Later we can add various input values as test data and node details. This then will cover scenarios like what happens if a customer tries to purchase a negative quantity of items, or if the total exceeds a certain maximum amount. We are now faced with another intuitive question. What's the discount percentage for purchasing more than 30 screwdrivers? Interestingly, we notice that this percentage is not specified in the requirements, although it's essential information not only for testing purposes but also for implementation. Therefore, we will create another balloon node to represent this query. Now we can include a result node in the model. Here we can describe what discount there is when spending more than 1000 euros in combination with more than 30 screwdrivers. Assuming that 100 euros was a typo in the requirements. We don't know the extra discount when buying more than 30 screwdrivers, so we won't specify an exact percentage for this moment. While modeling, I've encountered a question of whether there's a stack discount. It's worth noting that these kinds of inquiries often arise organically during the modeling process. Let's add this question to a balloon node for further consideration. Now let's look at our first decision node and model the no branch there. The question is whether we buy more than 200 euros. If the answer here is no, the next question is whether we spend exactly 200 euros. We include a separate decision node for this. We can now directly add an action state node to the no branch and describe that we are spending less than 200 euros here. In this way we have covered all possible test ideas in the model related to a purchase of more than 200, less than 200 and exactly 200 euros. We can now continue modeling and record all our questions, comments, ambiguities, etc. in the separate balloon nodes. What is clear is that through this method of modeling, we automatically encounter all matters that are still unclear, incorrect, etc. We will first have to clarify this before we can optimize and formalize the model. We therefore strive for a shared understanding within the entire team, including business stakeholders, which will be achieved through a comprehensive review session where everyone can contribute and provide input. Let's look at the complete model including all questions, comments, ambiguities, etc. as we have drawn it now. The model starts with a start node and an action state node. We have also included a first comment about the scope. We then included two decision nodes about the amount of the purchase and a question about a possible typo. Then another decision node regarding the number of screwdrivers and a question about the exact percentage here. And then of course a result node containing the calculated percentage of the discount. I also included a question about integrating with another program, prompting a test idea to access compatibility. And then the decisions about the number of screwdrivers equal to or less than 30 pieces, both leading to a result with a calculated discount percentage. The same for the total purchase of exactly 200 euros and less than 200 euros. In this case, both decisions lead to a result without discount. Then the whole part about drawing a colored coupon. There are many uncertainties about this. How does this exactly work in application? And for example, which color gives the discount? And what if you draw another color? Finally, the decisions regarding the number of screwdrivers less or equal to 30 pieces. and this applies to both the situation of a purchase equal to 1000 euros and a purchase between 200 and 1000 euros. Again, assuming that the 100 euros was a typo in the requirements and should therefore be 1000 euros. While finalizing the model, I came across another test idea regarding drawing a coupon in the situation where a standard discount has already been applied. This should not be allowed according to the requirements. Now, as promised at the beginning of this video, let's take a look at the remaining red exclamation marks in the model. Via the Test tab, we can see the description of the relevant errors. Let's fix the first error regarding the connector between the start node and the first action state node. The exclamation mark disappears. There's now only one error left, and it has to do with a mandatory missing outgoing connector from an action state node. Let's fix this too. Now there are no errors in the model anymore. After exploring and analyzing the requirements through modeling, and once the model is error-free, it's time to review it with the entire team. The TestCompass model is especially suited for this task due to its high level of abstraction and readability, providing to both technical and non-technical stakeholders. Our objective now is to address all our questions, comments, ambiguities, uncertainties and other points included in the model, aiming for a shared understanding. Subsequently, we can proceed to optimize and formalize the model. Let's now examine the feedback received from the team during the review and explore opportunities to optimize the model. The first balloon node, which mentioned the scope, was mainly a reminder to ourselves and was confirmed during the review. Thus, we can delete this node. Let's set aside the question of integration with another system for the moment. Then continue with the path where our total purchase is more than 200 and more than 100 euros. Here we included a question about the correct amount. Our suspicion was correct. Here 1000 euros had to be stated in the requirements and not 100 euros. We can now adjust the model accordingly and replace all instances of 100 with 1000 euros. Now regarding the query we had about the additional discount when purchasing more than 30 screwdrivers. The review has determined that this should be set at 10%. Let's incorporate this into the corresponding result node. In the review, the business confirmed that our assumption was valid and that there is indeed no stacking discount. Consequently, we can remove the balloon node containing our assumption. The section of the model covering purchases exceeding 1000 euros, along with quantities of more than 30, exactly 30 and fewer than 30 screwdrivers, is now finished. For the situation below, where the purchase is exactly 1000 euros, together with more than 30 screwdrivers, we can now update the discount to 14% in the result node. If the purchase amounts to exactly 1000 euros, together with exactly 30 or less than 30 screwdrivers, the discount remains at 4%. The next adjustment we need to make involves purchases ranging from 200 to 1000 euros, combined with more than 30 screwdrivers. We've determined that the discount percentage for this scenario now is 14%. The attentive viewer will now notice that we have already included test data in the details of this result node. The significance of this will be discussed in one of the following videos. The test situations below remain the same, resulting in a discount of 4%. The final inquiry on the right side of the model pertains to the possibility of receiving a message if a colored coupon is drawn. During the review, we concluded that such a situation should indeed prompt a message with a description, "Not possible to draw a colored coupon." We'll incorporate this description into the result node and remove the balloon node accordingly. Have you observed that by translating the requirements into a model using TestCompass in this matter, you've naturally explored, studied and gained insight into all functionalities of the entire tool discount system? You already have now a clear understanding of how it should function. Now on to the final section of the model. We are aware of the portion regarding potential integration and will adjust this later. Our assumption that there is only an additional discount when spending more than €300 has been validated during the review. Consequently, we remove this balloon note. Now regarding our inquiry about a €1 discount when drawing a colored coupon, it was found to be incorrect in the requirements. It should simply be a discount of 1%. We will make this update now in the result note and remove the balloon note. In the review, we examined the process of drawing a colored coupon and we can now model it correctly and in accordance with the agreed upon method. Additionally, it was confirmed during the review that indeed there is an integration with another system, further clarifying our understanding. The integration concerns a function in the external Wheel of Discounts app. Here you can turn the spinning wheel for a discount coupon. Only if you win a red coupon, you will receive an extra 1% discount on your purchase. As soon as you start modeling this, you immediately come across a number of test ideas, such as whether or not to choose the option to win a discount coupon, choose the option to win a discount coupon but not spinning the wheel, a test idea for the result other than winning a red coupon, and of course winning a red coupon with a result of a discount percentage of 1%. Let's model this complete part of the integration to the external Wheel of Discounts app further. We will now address the final error in the model, completing the formalization of our model for the tool discount system. It turns out that a result of winning a different colored coupon, yellow, green or blue, has an open end. We will adjust this. Now that the model has been formalized and agreement and shared understanding has been reached within the entire team, we can start generating the test cases automatically. Within TestCompass we have 4 types of test coverage forms, from weak to strong. We can relate the choice of a specific test coverage to the results of a performed product risk analysis. For now, we generated test cases based on the node coverage, which results in 8 test cases with 100% node coverage. If you now select the test case on the left, you will see the entire path in the model. All the information, including details like preconditions and test data, can be exported to an Excel test design. By doing this, multiple input values can be recorded for example, testing boundaries and edges, like what should happen if a customer attempts to purchase a negative quantity of items, or if the total exceeds a certain maximum amount. The test cases can also be exported as scenarios to Gherkin feature files. If it turns out that fewer test cases are needed for a specific test, you can disable them. As a result, you'll notice that the test coverage is automatically recalculated. In the next video we will look at other features within TestCompass, such as the export of test cases to an Excel test design or a Gherkin feature file. How we can add details to the various nodes in the test model, such as preconditions and test data. And we will show how the impact analysis in TestCompass works and how it gives us a very nice overview of the updates in the test cases after a change in the model. I hope this video has effectively demonstrated how to explore, analyze and study requirements by modeling them in TestCompass in an early stage. Additionally, the graphical model in TestCompass simplifies communication and collaboration and fosters shared understanding among stakeholders, leading to more accurate, structured and comprehensive risk-based testing strategies. Well, thank you very much for watching this video of TestCompass, where we have showed a practical example of how to start testing with analyzing, exploring and studying requirements by modeling in a very easy to use way.